Hello. Now we're going to look at an introduction to linear sequences or linear patterns. So we're going to do a little bit on language first. So we know that linear means something that is going to be like a straight line. So we are expecting that if we graphed the patterns we're talking about at the moment, that we'd get a perfectly straight line, that its slope, the slope of the line we're talking about, would always be the same. So we'd end up with a lovely straight line like we draw with a ruler. In terms of language, so we have linear, we know that that's line, so that's going to be a straight line. The other name for this type of pattern we could come across is arithmetic. So arithmetic means to add or subtract, or arithmetic means to add or subtract. So we're adding or subtracting the same thing each time. That's why we end up with a straight line. And we could either call these patterns or we could call them sequences. They're essentially the same meaning. The way that we test for a linear pattern, the way that we test for an arithmetic sequence or a linear pattern, whatever way we want to describe it, is the difference between each one of our terms always the same? Does it have a constant slope? Does it have a constant difference? So we have here a pattern. So we have term 1, term 2, term 3, term 4. If we wanted to know whether this was a linear pattern or an arithmetic sequence, how would we test it? Well, we know that it must have the same difference between each one of our terms. So how do we get from term 1 to term 2, term 2 to term 3 to term 4? What allows us to go from one term to the other? What's our rule that we're following? And is the rule the same every time? Well, to go from -4 to -1, we would add 3. And to go from -1 to 2, we would add 3. And to go from 2 to 5, we would add 3. So the first difference, the difference between each of our terms, is the same. It's constant. Therefore, this is a linear pattern. So the difference is constant. It's always the same. Therefore, we have a linear pattern. So this pattern is linear based on the terms we've got so far. Well, what about this one? 6, 10, 15, 21. Well, we know our test for if something is linear is we're doing the same thing. We're adding the same thing every single time. So here we're adding 4 and we run into a problem because here we're adding 5 and here we're adding 6. So our difference is not constant. It's changing all the time. So it's not constant. Therefore, it's not linear. And this is a very important idea as we get into more advanced issues. Is the difference always going to be the same? Is the first difference always going to be the same? And if it isn't, then we do not have a linear pattern. Now, what does the rule look like for linear patterns? Well, we know that if we graph these things, we should end up with straight lines. So if we know what the equation of a straight line is, that can guide us into what type of pattern we've got, because we know that we should end up graphing a straight line, drawing a straight line, if we drew out this pattern. Well, this is the rule for even numbers. So this is the nth term, we say. It's a rule that gives us any term in the pattern. So this would be the first term, second term, third term, fourth term in our linear pattern. Well, what does this rule do? It gives us a formula. It gives us an equation that allows us to create this list. So what are our even numbers? Well, if we have T1, that means n is 1 for this rule. So we put in n is 1 and we end up with 2. That would be our first even natural number. What would T2 be? Well, that means we put in 2 anywhere there was an n in our formula. That gives us 2 by 2 is 4. Would be T3. That would be 2 by 3. N is 3. And we end up with 6. T4 means that we have 2 by 4 is 8. So these are our even numbers. If we wrote them out in a list like we had here, we'd have 2 and then 4 and then 6 and then 8. And this would be term 1, term 2, term 3, and turn 4. And we could keep going. So this formula, this equation, gives us a rule that allows us to create this pattern, this even numbers pattern. But we don't have to just have a simple rule like 2 times n. We can have a slightly more complicated one like 3n minus 1. So we've got two things going on at once. That can still be a linear pattern because we may still be adding on the same amount each time. It certainly looks like the equation of a straight line, so it probably is a linear pattern. But how would we test it? Well, we'd sub in a few values for n and see if the pattern works out as linear. So T1 would be n is going to be 1. That's our term number is going to be 1. So we end up with 2. And the second term, we have n is 2. And the third term, n is 3. And the fourth term, n is 4. And do we have a linear pattern? Well, we have 2, 5, 8, and 11 are our different terms. Well, how do we get between each one of our terms? We are adding 3 each time. And here we had our even numbers were in a linear pattern because we were adding 2 each time. Now something might jump out to you about that. The difference between each of the terms is what the n is multiplied by. So the difference between each one of the terms is what the n ends up being multiplied by. And we can use that to actually go back the other way. If we had a list, how could we find this formula? And we're going to look at that as we go on. Now here, this immediately makes me think I probably don't have a linear pattern because I can see a squared thing going on here, and I know that that's not what I'd have for a straight line. It looks like a quadratic, but we can find our first several terms and see what happens. So we get our T2 and our T3 and our T4, 4 squared minus 3 is going to be 13. So when we've done that, we write out our terms and say, well, is this a linear pattern? Well, how do I get between each one of my terms? Here I'm adding 3. Here I'm adding 5. And here I am adding 7. So here my first difference is not constant. Therefore, I don't have a linear pattern. This is very important to have in the back of our minds as we go forward, that this constant difference between our terms, that the difference is always the same between each one of our terms, gives us a constant slope, gives us a straight line, gives us a linear pattern. And that's what we need for now.